question is from GATE 2020, Mechanical Engineering Paper Set 2, question number 40. A rigid block mass M1, which is of 10 kg, having velocity V0 as 2 meter per second, strikes a stationary block of mass M2 of 30 kg after traveling 1 meter along a frictionless horizontal surface as shown in the figure. The two masses stick together and jointly move by a distance of 0.25 meter further along the same frictionless surface. Before they touch the massless buffer that is connected to the rigid vertical wall by means of a linear spring constant K is equal to 10 to the power 5 Newton per meter, the maximum deflection of the spring is dash centimeter. Let's first understand the system that is given and what is happening in the system. So in first part, it is given that mass M1 of 10 kg moves with a velocity V0. This travels a distance of 1 meter and there is a mass M2 kept here, which is of course stationary, not moving. When this mass M1 goes and strike M2, these two together travel with a new velocity. Let's call that velocity V for a distance of 0.25 meter and then hits this buffer, which is massless. Of course, when they hits the buffer, the spring is going to get compressed because the buffer will move towards the left. This spring with a spring constant K will be compressed. So in the first part, what is happening is a perfectly inelastic collision. So there are two masses M1, M2. Collision is going to happen if they come in contact. Now in this case, when M1 collides with M2, they together move with a new velocity V. So first thing, the collision is inelastic. M1 is not coming back. And second thing, it is perfectly inelastic because M2 was stationary and M1 was moving. M1 then got attached to M2 and together they moved with a velocity V for a distance of 0.25 meter, of course. So we can write M1 V1, or we can say M1 V0 is given here, plus M2, and the velocity of M2 was 0, will be equal to the momentum before collision is given on the left hand side, will be equal to the momentum after collision. Momentum after collision is M1 plus M2, both masses are together and they have the equal velocity of V. Hence, we can find out V from this equation because M1, V0, M2 are all known values. Hence, we have V is equal to M1 is 10 kgs, velocity V0 is given to be 2 meter per second, divided by, this is nothing but 0. So, M1 plus M2, 10 plus 30, that is 40. Hence, we have velocity V with which the two masses are going to go forward is 0.5 meter per second. Now, when we know with what velocity M1 and M2 combined masses are moving, we can find out their kinetic energy. After these masses collide with the buffer, this complete kinetic energy will get stored in the spring in form of potential energy, elastic potential energy. So here we can use the energy balance equation and find out the answer. So second thing we can write using principle of conservation of energy. We have to just add the energy in the system, half into mass that is moving is M1 plus M2 together into V is their velocity, V square. This is the kinetic energy possessed by the masses when they are in motion is equal to the potential energy stored in the spring, that is half K into X square, where K is the spring constant and X is actually the deflection of the spring that we have to calculate. So this value is the unknown. Hence, we can keep X square on one side, take everything else on the other side. We have 2 upon 2, 2 in multiplication by 2 into M1 plus M2 is 40 into V is 0.5. Let's write it 1 by 2 whole square divided by K. So we will write 1 upon 10 to the power 5. Hence, X will be equal to, just computing this, so we get 10 upon 10 to the power 5 square root of this value in order to find X. So the answer that we have here is 1 upon 10 square. This value is in meter because all the terms we have substituted in SI units, kg, meter per second and Newton per meter. So we can convert this in centimeter because we are being asked in centimeters. So just multiplying by 100, we get 1 centimeter. So let's just fill in the answer. This is 1 centimeter. To learn about more collision problems and to learn the theory of collision, you can refer to the NPTEL video, Module 1, Lecture 16, Relook at Collision Problems, from the course Special Theory of Relativity by Professor Shiva Prasad, Department of Physics, IIT Bombay. I hope you understood this solution. Thank you.